You just keep your mind. I'm not just recording it. Thank you for the reminder. so, so you can do fruits and products, countries and products in that regard. I believe that does make sense.
Can I ask an applied question?
And what?
An applied question, kind of.
Okay, what
if you have a database that contains these countries, products, and fruits,
okay,
or say 1 million entries,
okay.
can we use the same procedure to generate this table?
It depends on what you want to achieve with it. If creating this table,
we're trying to achieve this same table to say how many times did Ghana or Apple appear under Ghana, how many times did that kind of gold appear under Nigeria, to just the same table you have just generated now. I'm just trying to say, if there is a big database of say 1 million entries and all these things are just there, a summary table kind of, can this same command give us this same summary table?
Yes, you can do that. If you can access the data set through the R environment, you can do the same thing. You can do the same thing. But there is a way you can write a script to do the same thing in the R and the maybe MySQL, maybe Oracle or the likes. You understand what I'm saying?
No.
It's just like this is just like a pivot. It's like a pivot.
Mm-hmm. Yes.
And you can do the same pivot in Oracle SQL. You can write a script to achieve this too.
Okay.
Yeah. But if he says I want to do it in R and just put table and put this thing instead of writing a script, if R can access the data in form of maybe Excel or something, you can achieve the same result with it.
Okay, let's go.
Okay. So, let me see. Okay. So as you can see here, so you might want to do some kind of work for. If you talk about selecting part of the table. Okay. You can, as you can convert to the data frame, you can also convert to a table. So look at this place. What I just wrote here is as data frame. What I mean is that this particular data I'm calling, convert it to a data frame. That's what this as data frame means. So if you want to convert a particular object to a table, now look at this, my tab. My tab is a data frame, right? Because I use the data frame function to create it. Now, maybe I want to, as I created this table using this table, my tab, I want to save it to an object. So maybe I want to convert this data frame to a table. What I will just do is use the as.table method and pass the object I want to save as table, which is my tab. Then I can save it to a particular variable, say table tab. So this is going to save the table format of this data to this particular variable. I guess you understand what I'm saying.
Please, can you come again?
This my tab is a data frame, right? Because I use the data frame function to create it, right? Now, I want to convert it to a table and save it to a variable. So I can just use as dot table of this. So and save it to this. Do you understand? So it's going to save it.
A table instead of from data frame to a table, right?
Exactly. So if I should run this, you can see what it's giving me. Cannot coerce to a table. The reason being is that it's the way the result is generated, it cannot coerce to a table format because because you have a table for gas, another one, so there's no way you can coerce it to a table. But I can achieve the same results. I can do this one that has two, just forming a table with just two columns to as the table. So instead of putting the old data frame itself, you can put this guy. Then we convert this to table. It's giving me an error. It's giving me an error. But then I can try to remove this guy and still put this guy and still call this instead of. The reason it's giving me an error is that it's already in table format. For that one, it's already in table format. In that regard. So this is the table I have. This is the table I have. So what as the table does is that it takes the table itself. It takes the data itself that is not table and converts to a table. But me saying as the table and I'm putting like I'm performing kind of table operation doesn't make a lot of sense. But this guy is already so table of this takes to this object, so it's already a table. Unless I want to do something like this again. Say okay, table as the table, something like this as the table of then I will call a data that has two columns. I'll call a data that has two columns instead of the three columns. So I'll call the first two columns of this my tab. So I'm taking all the rows, so nothing specified in the first parameter. Then 1 to 2 specify that okay, I just need you to do as the table for the two columns that is there. I think this should work right now. Does it still work? But then you can still achieve the same results using this tab. This is table, but I don't know why it's not working. So now, okay, if you want to confirm, as I've saved this guy into table tab, let me create it again. As I've saved it into a table format, you want to check whether it's actually a table. You can use the is.table to confirm. Then pass the parameter, the object is saved as table. So if it's a table, it's going to return true. If this guy is truly a table, it's going to return true. You can see that it is true. So it's a table. Now, this guy that we created in this form here, this one that we did that of the whole particular data frame that is now split into groups for gas, for gold. So if we want to add this guy in the same as the whole table instead of split in different groups for products, you can use what we call the F table function. F table, which means flat table. Now I cannot specify my tab. Now you are going to see the difference between using a table and the F table. Now look at this now. So this guy is going to put the first take the first two elements. It took the first two columns, puts and countries as rows, then the last one as column. So instead of it to be splitted in categories, so it has already compiled it together. So this one is for category Apple. For Apple, you have countries and products as is comparing countries and products based on the fruit. So for Apple, cargo and product does not exist. Cargo and gold exists once. Cameroon and gas exist once. Nigeria and oil exist once. Then after we've done this categorization for Apple, then it goes to banana and do the same thing and compare. So that's that.
I think this looks like a better presentation.
Yes, exactly. Now, there's another way you can write this again. I can write this, I can achieve the same thing doing this. Flat. Then I will say, okay, which one do I want to be as columns? Say products. So model products with fruits and plus countries. Fruits and countries. So plus like that you are taking food and countries as modeling it in terms of products. So fruits is going to be the columns. I'm sorry, product is going to be the column, and food and countries will be the row. So it's going to generate. She generates it in this kind of format. But you have to, Are you calling my attention, sir? So then specify the data, which is my tab. Oh, sorry. Not, I'm supposed to type F table, not flat. F table. Sorry. So you can see that the same result is achieved.
Okay.
So this one is saying, okay, model the products with fruits and countries. I'm picking the data from this guy. So if you want, maybe countries to be the column, then countries will be here, and model it with maybe fruits and products in that area. I hope we are making sense.
Trying.
So this function, this sign means we are modeling this guy as a function of this guy. You are going to see it when we are talking about linear regression, linear model. You're going to see something like this. So let me even do something like, okay, let me call the Iris data. I just want to give you guys a kind of data. I'm not supposed to jump to this anyway. So let's say, okay, let me use this. Let me use chicken wings. Let me use chicken wings. Chicken. Sorry. Chicken with. So let me say, I want to model. Let's forget about this. All these columns that we have here. Let's say I want to build a linear model. That's a linear regression model. So if you look at these 4 columns now, what do you think is going to be your y variable? That's your dependent variable, and which one is going to be your independent variable? I believe we understand the concept of linear regression.
You ask a question?
Yes, sir.
And the weight should be the independent variable.
Independent or
The
dependent?
weight should be the dependent variable, sorry.
Okay, yes. So
Weight should depend upon time and the diet.
Yes,
and
exactly.
the type of care.
I want to create a linear regression model. So LM, then you type
weight.
So you are modeling weight. Now write, put this sign. Weight in terms of time plus
Shake and diet.
plus diet. Then now say, cannot say that's just checking weight. So this guy just created the linear model. You can see the formula is going to weight in terms of this. So I'm going to get into this. So this is your
Intercept.
intercept and blah blah blah. This is kind of a multiple linear regression model because it's not based on. It's just you have like more than one independent variable. So we are going to go to this later on. So let's see. Now let's talk about the applied function.
Sorry, Iman, sorry.
Yes, sir.
I was expecting like when you use Excel to do these linear regressions, it will just give you one coefficient, one intercept, and each coefficient for the independent variables. Why is this one giving me like a table form?
Yeah, we're going to get to this when we talk about the advanced analytics. Advanced analytics, talk more about this. So if you might want to see the values that was predicted, the predicted value. So I didn't assign this to have to pass this as a parameter. I didn't pass the model as an object to an object. So that's how I'm trying to copy this. So this is the value that was predicted for. So he's saying that this is the for the first, this is the predicted value in that regard. But we are going to talk more about this later. We talk about the apply function. So there is something we have here. We've created a table called my table tab. Is it table tab or yeah, this guy.
Yes.
Comparing fruits and countries. Suppose we want to get the overall total. So we can do something like this. Sorry, please give me a minute. Okay. Okay, so maybe let me call the table again. So table tab. Okay. So I want to do something with something. And let's see what we are going to do. Let's say I want to find this guy. So let's see what this guy is going to do. So let me pass my tab, my table tab, which is the data. Can we all hear me?
Yes, I can.
So this guy gives us the overall total, which is the 10, which is 10. 1 plus 1 plus 3. That's the 3, 4, 6, 9, 10. So the overall total. But if I want to find the overall total based on column, so I can see margin and specify inside margin equals to 2. So if I want to find the overall total based on column, I should do this. So Cairo has 1, Cameroon 1, Congo 1, Ghana 3, Nigeria 3. But if I want to find it based on row, the margin will be 1. The margin here will be 1 instead of 2. So I have apple to be 3, orange to be 3, and orange banana to be 3, and orange to be 4. So I hope that makes sense. So another way to achieve these first two, I can do a row sum or a column sum. So for this guy, a column sum should achieve the same result for this guy, while a row sum should achieve the same result as this guy. So let's try and do a column sum. A column sum table tab. So you can see the result here, the same thing as the result here. So the same thing as the result here. So if you do a row sum, the result here, you are going to achieve the result here if you do a row sums. So do you understand that? You can also find proportion. So how do you find that? Up to table. Now this guy give us the proportion based on the the overall sum. So it's saying, okay, this is the table 1 over the total sum, which is 10, 0.1. This one over 10, this over 10, this over 10 is this over 10 is this. That's what this guy gives us. So I don't know, I should be able to find the proportion based on column and sum. So I think I should just put the margin. I can just put the margin here. So I want to find the proportion based on the column. So I'll put margin is 2. Yeah. So this guy is giving me that, I have what's the column sum again? This is 1 for total Cairo. So it's saying that 1 divided by, so the value here is 1. 1 divided by 1, 1. 0 divided by 1, 0. 0 divided by 1, 1 divided by 1, 1. 0 divided by 1, and in that regards. Now let's come to Ghana. What's Ghana doing? 0 divided by 3. 0 divided by 3. 3 divided by 3, 1. What's Nigeria doing? We have 1 here. So 1 divided by 3. 1 divided by 3. We have 0.3333. We have 2 divided by 3, 0.666. That regards. So it's doing the proportion based on the column. You understand what I'm saying? Hello.
Hi.
Can we move on?
I think we can. For somebody like me, not because I lost the last class. Most time I'm trying to catch up as you do what you're doing. So if you don't hear me, it means I'm just trying to follow you.
Okay. If you are not understanding some part of it, you can just tell me the part you don't understand. Yes?
It's okay.
Let's quickly go over the margin function again because I'm actually trying it out on my R Studio and I'm not really, I think I'm missing something. So just quickly go over, please help go over what the margin function is all about again.
So this guy, the margin of table for the table called table tab. Let me call the table tab so you can see it again. This is the table we have. Now margin of table of this particular table is giving me the overall total of the entries we have here. So it's going to find the sum, everything from top to bottom. So the sum here is 3 plus another 3 here, which is 6, plus 4 here, which is 10. So this should give me 10 as the result, as you can see here. Now, this one is saying that, okay, give me the overall total based on the column. That's why I have margin equals to 2 here. So based on the column, so for column Cairo, you should have 1 here. Then this one 1, then 3, then 3, then 1. So it's giving me the total based on column. But if you want this, you have 1, 1, 1, 3, 3, and 1. Now this one is going to give me the overall total based on rows. So how many rows do we have here? We have apple, banana, and orange. So it's going to give you the total based on rows. So for apple, we have 3 as the total. For banana, we have 3 as the total. But for orange, we have 4 as the total. So if I should run this, I have 3, 3, and 4 in this regard. Do you understand to this stage?
It's okay. I understand. Thank you.
Now, these column sums, these co-sums, it's going to achieve the same result as this first guy here. This guy here. So it's finding the sum of the columns in the table. It's finding the sum of the columns in the table. I can use call means. I can use call means to find the average for each column. So in that regard. So now this crop dot table is going to find the proportion based on the total overall total. So the overall total of this table is 10. So this should give me 1/10 for this first entry here. This one is 0/10, 0/10. So it's going to divide every entry here divided by 10. If I should run this, you can see everything has been divided by 10. Now, if I should do this second one is doing the finding the proportion based on the overall total in columns. Now, first of all, let me call the table again. So what this crop dot table margin equals to is, okay, first of all, what's the total sum in this column? 1. Divide every entry here by 1. Go to the next column. What is the total? 1. Divide every entry here divided by 1. Go to this. What's the total? 1. Divide every entry divided by 1. This is total 3. Divide every entry here divided by 3. This is total 3. Divide every entry divided by 3. That's 1/3, 2/3, 0/3. The total here is 1. Divide every entry divided by 1. So if you should want this, so for this, divide every entry divided by 1. Divide this by 1. Divide this by 1. Divide this by 3 for Ghana. So that's why you have 1 here. Divide this by 3. 1/3 gives us this. 2/3 gives us this. 0/3 is 0 in that regard. I guess we understand that part now. Okay. There's no more. Now, this, let me call the table again. Table tab. This is our table. Now, if I want to, I don't want to use this table again, or I want to convert this table to a data frame. What it's going to do is that, this is the place where we created data frame. So it's going to create a data frame having these two columns, fruits and fruits and countries. You know, the data frame was created using fruits and country. So if I want to get the data frame, the table back to the data frame, so I just use the as.data.frame function, as.data.frame, then pass the table there, called table tab. I didn't put M here. So as you can see here, it has returned this table I have here to the data frame format. So the extra column I have here is the frequency there. You can just remove it. So it has created it back in the data frame. So apple and Cairo, banana and Cairo, then it has been returned to the data frame. So you can save it to an object if you want to use the data frame format of it. So I guess we understand that. Okay, so let's move to the part of descriptive statistics. We'll be able to cover that as fast as possible. So I want to ask, do we think uh, I should, you need this script, maybe I want to use it for revision, so I'll just save this script and send to us via mail, or what do you suggest, so that you can use it to practice on your own, if you have the house to do your own.
That's fine.
Okay, so I will save this as descriptive.
Since it's recorded, will it not be in the records?
It will be there, but this part of it. So it's flexible. When you have the scripts, you can go through it again, over and over again. So it's can also save the stress of having to type and to see the script.
Okay.
So let me create another script called. This one will be the next session. Functions. We are talking about functions and functions. Please give me a minute.
Pause the recording as well.
I can't pause the recording. I have to stop it.
Oh, no, don't. Okay. Don't stop it. Just leave it.
All right. Let's continue. So let me create. I don't have this. I don't have this. So let me create a vector. Let me create two vectors and try and combine them. So you can use cross fertilization. So I want to create a vector. So I want to create a vector, say x let me say 60.92. I'm just following the material to do this vector. I can create a vector combine. Any kind of vector, so, but I'm just following the material. 50.4. So this one vector. So I create another vector. So don't mind the less than and minus sign and I'm using. You can use equals. You can use equals to. It's still the same thing. Just like in the traditional we have. Want to see something? So I'll combine these two. So call it xy. I hope you understand what C binding is. X comma y. So let me call xy. So this is our xy. So it's I can also combine it. So it forms a. You see how combines works. So just like it updates it from the bottom. X comma y. This is how combine is looking. So what are we trying to achieve with this? Since you are talking about functions or groups. So this, by default, it gives you the column name x and y. So the column is column x, this column y, and this is like the default row names generated for it. So in this case, so let's check the class of xy self. Let's check the class of xy. So this thing is I'm typing in the matrix. It's going to be matrix. We can create a list. I think we know how to create a list. We know how to create a data using the data format. We can also index. I believe you know how to index with vectors, matrices, data frames, and network. Right? Using the can use the position of the vector, the matrices, or the data frame. You can use their name, the column name, and the data frame. Or do we need to go over that again?
Indexing. Yes, please. Thank you.
So let's see. I want to call this 16.92. I want to call this 16.92 as here. 16.92 is in row 1, column 1. So I will type x, y, since that's the data. Column 1, I'll be row 1. First of all, row comes first. Then column 1. I have 16.92. Now, suppose, okay, I want to return every element in the row for all the columns. So this is going to go in this way. X, Y. So I want everything in row 1. So I'll put row 1 here, comma, everything in the column. So return everything for each column in row 1. So this one specify row 1. Then if I don't put anything in the second argument here, it means that I want every column to be returned. So this will return row 1 regarding to x and y. So that's 16.92 and 8.37. As you can see here. Now, suppose I want to return from row 1 to row 3. And I want all the columns to be returned also. So this, I can do this. So row 1 to 3 for all the columns is returned. Now, what if I just want row 1, row 3, and row 4, and I just want the column 1 to be returned. I don't want the y to be returned. So I'll say xy. So for the first argument, I need column 1, so row 1, row 3, and row 4. But there's no way I can write it in terms of a sequence. You know, this is a sequence. These are saying that 1 to 3. But 1, 3, 4 now is not it does not follow a sequence. So I have to create it in terms of a vector. Say 1, 3, 4 to specify for the row. Now for the column, I just want column 1, which is the x part. Just put 1 here. So this gives me 16.9 to 7.62 and 15.49, which corresponds to this guy, and this guy. I guess you understand that part.
Yes.
You can also index with the column name, or the, since you have a column name, maybe I need for, so this is a double square bracket you use. So I need for column x. Oh, subscript at, okay, is it capital letter? It's not capital. I want to check something. Names of xy. Okay, it is not. It's not what I think it is. It's not what I think it is. I can't index in that regard. Wow, that's column names now. That's column names. Okay. I was okay. Found something from you. Sorry. Let me just copy this. It's giving me some bad vibe. Oh god. All this. Okay. What if I do this? Okay. I don't know. I'm having it to use the shortcuts to run it. Since it's giving me this kind of. Okay. Let me do another script. Okay. I think it should be fine now. Okay. Now I want to index using the column name. So let me do it. Let me do this. Okay. So do we get that? So this for column x and column x, all the rows and column x. So maybe I need for y too. I'll just specify here. So I have this. So is that part understood?
Yes.
Okay. So let's see. So it works for whether be it data frame, vector, and rest of them. You can just explore and go through. Okay. We are talking about function, but I've not said anything about function. But first of all, let me talk about some stuff. So I can also now let's say I want to do something like this. I want to divide all the columns, all the entries in column X by 2. I can also perform arithmetic operation with it. So I can just copy this here. Then I put here. Okay. Then I just move for Y in this regard. And I put divided by 2 here. So you can see all the entries here are divided by 2. So suppose I want to append this result to this data itself, to the XY data. So what I'll just do is that, okay, I'll say XY. So where is it going to be? Okay, like I will say, okay, I want it to be another column, another column. So I'll give it a column name. So I'm thinking of the name I should give it. let me call it Z, another column Z. So this is equals to, so this guy is equals to this operation. What's it saying? The same subscript back to ground. One, two, three, four, five. I don't know why I'm having that result. Okay, let me just put X5. But no, this is not good. Okay. Sorry. Just 2 dimensions now. I don't know why it's giving me this error. Sorry. Let me call my XY again. I think I've tampered with my XY. I think I've tampered with my XY. Okay. Okay, I have this. Let me try and run this again now. So let me try and call my XY again. Okay, still there. So let me try that operation again. Wow. But this shouldn't give me what I want. It's not what I want. So we'll come back to that. So I can also assign variables. I can assign multiple variables. So, like, or I can write, let me say I can write statements or codes in a single line. Let's say I want to say, okay, x is equal to 2. Instead of saying x is equal to 2 here, and run this and come to the next line and say y is equal to 3, and come to the next line and say y is equal to 4. And say maybe you are running this one by one, or you have to highlight everything and run it here. Then come and call it here, say x, which is 2. I can do this. I can say x is equal to 2 here. Then I will end it with this colon or semicolon. I'll end this with this semicolon. Then I'll come here and put y is equal to 5. Then I'll end it with another semicolon and z is equal to 10. Then end it in this manner. So I don't need to end it. I just say that's the last. Then I can do this. So if I call my z now, it should give me 10. So I can write it in a single line by saying that, okay, this is where this first part has ended. This is my first, we are on this again, then in that regard. Now, let's talk about the conditional statements. Let's talk about conditional statements. Now, I can say, okay, I can tell, okay, using this XY data that I have here, let me call the XY data again. And sometimes you have to deal with conditional loops and conditional statements. Say XY, let me call this XY. Let me call my original XY, which is this guy. Okay. Sorry, I've defined another x and y. Sorry. Let me call my x again. So this is my xy. So I can say, okay, go through this column x that I have here. Give me the values that are greater than 15. Now, there is one way, there is another way. So I'll give us two ways of doing this. I can write an if statement. So if I don't want to write, I don't want to put a for loop, an if statement inside a for loop, but maybe I might have to do that. Maybe I have to do that. See what is going on in my head. I have to do that. Okay, I can say for I in, I will explain this. For I in range, I have to put this here bracket. For I in 1. So first of all, let me do a basic for loop so that you understand what I'm writing here. Return I. Before we now go into this is giving. I wasn't expecting that. Yeah. Or let me use the print function first. So this is what I was expecting anyways.
Is that going to be our setup?
Yeah. What's that? So I was like, okay, for I in this sequence 1 to 10, print I. So I goes, so there's a sequence 1 to 10. There's a number 1 to 10. Are you guys still with me?
Yes, I am.
So for a sequence 1 to 10, now I'm telling you that, okay, I should go inside that sequence. So for each number you find in 1 to 10, print them. So I goes inside. First of all, you find 1, it prints 1 like this. It goes to find 2, till the end of this sequence, it prints to 10. Now, do you understand this first part is actually very, very trivial? Do you understand what this guy did now? Right? Before I move to the next thing, do you understand what that guy just did?
It's not the same thing.
I copied the same, but I want to edit this second line.
Okay.
Now, I want to now put a conditional statement inside now. So I will now say, first of all, I want to show you something before. So if I do 2, I want to do 7. Okay. Now I wasn't expecting this. Okay. I don't know why it's giving me error. That's what I want. But I'll just do another thing. You know? I'm looking for a function, but I'm not seeing it here. I'm looking for a function. I'm not seeing it here. But then I think I've used this function before. I think I've used it before. I don't know why it's not giving me. Okay, this is what I'm looking for. So this is 7 modulo 2. You know what modulo is? This is return remainder. Okay, 7 divided by 2. What's the remainder? 1. We're going to return 1. If I do 7 divided by
Can you try zoom this work a little?
Okay.
Thank you.
Zoom in.
Okay.
Zoom in.
Better.
Is it better? Okay.
Yes.
If I do 7 to this guy, I'm going to return 3. Also, I'm saying that, okay, what's the remainder if I divide 7 by 4? So what's the remainder? The remainder is 3. What if I should put 2 here? What if I put 2 here? What's going to be the remainder?
No, let me, is 2% 4, right?
Yes.
Okay. Continue from there.
What's going to be the remainder?
How do you mean?
This percent means modulo. That is the remainder after divided. Okay, if I say A modulo B rather, it means A divided by B, return the remainder. So if I should say 2 modulo 4
Okay.
now, what's going to be the remainder of 2 modulo 4?
Is there a remainder? I don't think there's a remainder now. 2 divided by 4 is not half. It should be 0.5 or something now.
No, it's
There's no
integer.
remainder.
It's integer division. It's integer division. So it's not. There's nothing like half.
Oh, okay.
So what is the answer?
So the other is because 4 cannot divide 2 because
2 cannot divide 4.
So 4 in 2 is 0. What is it going to be left? 2. So the answer is 2 as you can see now.
Do that mathematics again. It says 4 into 2.
So
are you dividing 2 by 4? You are dividing 4 by 2.
You are dividing 2 by 4.
And that's why Susan say is 0.5.
It's not 0.5.
There's nothing like point there.
There's nothing like point in the modulo now. The modulo. So it's like okay. It's like I give you 10 naira now, and I say divide it between 4 people. There's no way you can divide 10 naira between 4 people because you have to say, okay, first of all, if you divide it by 2, that's 5 naira. Okay, 5 naira still exists. Now, how can you divide 5 naira to 2 people again? That's 2.5 naira. You cannot give 2.5 naira to someone. So it means that you can't divide it into 4. So you can't divide 2 into 4 places. So that's 0. So it remains 2. But normal division is going to be 0.5, which is half. But in this case,
okay,
you are not taking decimal into consideration. If it's going to give you a whole number. So if I should put 7 here, if I should put 7 here, this one is saying, okay, how many times 4 is going to go in 7? That's only once. And it's going to remain 3. So it's going to return 3 as the answer. That's the remainder. So it's going to return the remainder. Now, if I should put 8 here, 4 will go in 8 2 times, right?
Yes.
Without any remainder. So the answer here should be 0. So as you can see here.
Okay.
Now I want to put this condition. I want to put this condition inside this loop now. So what I want to achieve here is that I want to find the even numbers between 1 and 10. So how can I achieve this what do you think I can put? That okay, for I in this value, okay, I should go inside this value and return all the even numbers inside. These are the simple tricks and logics we use to manipulate some things. You want to get a particular result, so you have to use loops. You have to use conditional statements because using loops might not be enough. You have to use some put some conditions in place, and that's how real life situation works. You have to put some conditions in place to get a particular result. So you have to know how to put your thoughts in quotes and achieve your result. I'm waiting. You have 3 minutes to think about it. What is that statement I will put there? That will make me check whether the value I want to get to return is an even number or an odd number. That's the simple logic. If you can find that logic, then you should be able to do the remaining part. So the logic is this. I'm not saying the answer, I'm just giving us. So the logic is this. It's going to check if condition, then result, something like this. So if this condition is met, then do this. So if this condition is met, then do this. So that's what I want to put here. If what is the condition? There's nothing like check even or even kind of condition in R. There's no function like that. But how can you now okay, if there's the function like that, okay, we don't know the function, but how can you now use some little mathematics here to now check for a condition whereby something is in? Okay, let's just go back to basic mathematics now. So what are even numbers and what are odd numbers? So let's go by that. Whether we can compare, think about something.
Between 1 and 10?
No, generally, what are even numbers, what are odd numbers? From that definition, you should be able to point something.
So what are even numbers?
Yes, that's what I'm asking.
I thought you were telling us.
No, I'm not telling you, I'm asking. Okay, what are the even numbers between 1 and 10?
Even numbers are numbers that are divided by itself and 2 without the remainder.
Okay, perfect. Why odd numbers is otherwise, right?
Yes.
Now, so how can we now coin in something from that definition? Even numbers are numbers that can be divided by itself. No, let's go by itself now, because odd numbers can be divided by itself. It can be divisible by 2 without remainder. So how can we now put that logic inside it?
There's if I is
okay,
if I is divided by 2, but how do you put that?
You cannot put divided by. You want to check whether the remainder is there. You cannot.
If I, okay, maybe Susan will help.
So you know what we did there? We are checking for the percentage. We are checking for the remainder.
Yes.
After dividing by a particular number. So what do you want to check here? What do you want to check here?
If now if you assume that I is 8.
Okay.
And the modular should be 2. Does it make sense?
If I is the what?
Kai, just help
Huh?
us out. Or help me out.
Okay, so can you help us?
If I this without a remainder, it means the 2 digits should be such that when they are divided, there won't be a remainder because the remainder is 0.
Okay, yeah. So how do you write that in the environment?
Maybe something like with condition true. Have we?
Mm-hmm.
If condition, I don't know what's the condition. Okay, if I is equal to 2.
No, you can't say if I equals to 2. All even numbers are not equal to 2.
Sorry?
You can't say
numbers.
all even numbers are not equal to 2. You cannot use that to check for even numbers. The definition we just give is that okay, even numbers are numbers that are divided by 2 without any remainder. So how do we use modulo to explain that? So I is the number we are
So what?
Now I is the number we are printing. So how do we know whether I so I is going to go into values from 1 to 10 now. So okay, if I picked 1, how can you check whether I is an even number or an odd number? Okay, let's just see. How do you check whether I is an even number?
If the modular is 0.
Modulo with what? If the modulo with what is 0.
Then the result is 0, sorry.
Which result? Which result?
The result we get.
If I is divided by 2,
no,
and it gets to 0.
We are not using divided by
It will be what would it will now be if what do you call it now? If I is a variable, right?
Yes.
So what if we say if I modulus 2 equals 0? What?
Yes, exactly. This is what I want. You not use equal to now, you are going to use assignment operator, which is equal double equal to. So you are saying that if I modulo 2 is 0, then you are sure that this is an even number, right?
Yes.
Then print I. So what is going to happen now? I is going to check, is going to go for 1. If it satisfies this condition, it's going to print it. If it does not, it will go to the next number. So any
Why
number
do we use 2 equal signs?
Yes, you are doing comparison. You are not assigning. If you are using 1 equal to, you are assigning. So if you are doing comparison, use 2 equality. So this should give us the even numbers in this series, in this sequence. That is that now. So let's try and use this. We have an error here. Okay, let me use the return. Let me use the return. Okay, let me use the return. I don't know why I'm having here. There
was supposed to be a bracket or something. This one, what if we put it in parentheses? If we put the condition in parentheses,
yes, exactly. Yeah, I think so. Yeah, exactly. I think they just use that regard. So exactly, yeah, exactly.
Yeah.
So you can see this. So what if we want to print the odd numbers there? So what is the tweak? What is the thing you are going to tweak in this loop that we have done, in this conditional statement we have done? Yeah, you said?
Like if it is not even, then let's return the odd numbers, right?
Yes, yes.
If you just now, else is it bracket that be another bracket now?
No. Okay, now you have printed the odd numbers. The even numbers rather.
No, even
Okay.
numbers.
So now we don't want to put the even numbers, we want to put the odd numbers. What do we do?
And the next, because you do since the if here already, this conditional statements is here. If this, else, whatever, the next stuff.
We need to use else. We just need to change this one to not equal to.
How do you write
Which one?
otherwise?
We just put not equals to here. So if I modulo 2 is not equal to 0, print I. Print I.
Okay, so that is, what sign is that? Is a exclamation?
Exclamation mark.
Okay.
I think you should be able to use this too. Let me see.
So when you use exclamation,
Yes.
it means it's not equals to.
Yeah.
Okay. Why do we use only one equal sign now rather than comparing?
No, this using not equals to is like a comparison too. But if you use one equal sign now, it's not going to work out. It's not going to go well, as you can see here. So you have to use equal to compare.
So put the exclamation sign and use two.
You cannot use 2 equals to like this, no. That's no.
Okay.
So, as you can see here. So I just we just use the logic here to print even and odd numbers, right? So now let me see our x and y. So I want us together now to reason. Okay, how do I write a for loop here to print? Okay, let's just say I want to go into this set now. Are you with me?
Yes.
So I want to print this data set based on the condition on the x column that are greater than 15. I don't know whether you understand what I'm saying.
Okay.
So if you check this row, for this row now, for it to return this row, this entire row here now, if this particular x entry, if it is greater than 15, it's going to return everything here. Then it comes here. Is this guy greater than 15? Yeah, return everything. Is this guy greater than 15? Is this guy greater than 15? No, it's not going to return this. Is this guy greater than 15? Yes, to return this. So it will return. So we have to write, I want to write a for loop that's going to return this result based on whether the entries in the x column is greater than 15. So how do we achieve that?
For I in X, Y.
Okay,
For I.
Okay, let me put this out in here. Okay. For I in
X,
Y.
Y.
Okay, let me put the brackets here. Okay.
If bracket open, I modular 15.
No, it's not modulo in this case. It's not modulo.
What is it going to be?
I said, okay, I want this guy to return based on whether the entries in column X is greater than 15. It's greater than 15. So then we can also help us.
Yeah, I'm trying to figure it out.
I was thinking if we use the previous equation and edit 2 for 15.
No, you are checking. You are checking modulo in this case. It's not modulo. You are checking whether a particular entry in a column is greater than not modulo. Now you have to be careful the way you write this. You have to be careful the way you write this. So, yeah.
Okay.
This is a Mr. question with us. I can't see it because I'm using the house.
Yeah, I'm here. I just did it on my system.
Okay, thank you. So should I rescue us?
Yeah, let's take the purpose out now. Let me talk about.
Okay, then Papa, do you want to help us?
I've written this section.
Okay. Okay, can you share your screen so that you can show us or what? Do you mind telling me your screen so that I can show us what it is?
I'm sharing.
All right. Okay. If I get that equals to 15. Yeah, it makes sense. It makes sense, but what you did is that I is going to go through everything inside the data. Now,
Okay,
so I just want first of all, this first statement that you said for I in X1. What this one is saying that I is going to go through everything inside the data, whether X or Y column. Now, this second column is saying that for each I in everything, check if it's greater than or equals to 15. If it is, print it. So it is printing all the results based on all results that are inside the XY data frame that are greater than or equal to 15. But what I want to achieve is that for it to return a particular row in the data, so I want the results should be in a kind of data frame format, not the listing format as it is there. So for each particular row, it should return a result based on the entry in column X that are greater than 15.
Okay.
No, this makes a lot of sense. Yeah, this makes a lot of sense. So let me share my screen. So it's just to get the concept. You get it, but it did something that is nice. So what it did is that to come here, is this guy greater than 15? Yes, return it. It will come here. Is this guy greater than 15? No, it will not return it. It will return this. Return this. It will return this. It will return this. It will return this. And I think it's just one. I don't know. I think your own XY is different from my own.
Yes, it's different. I had different trial.
So if I'm trying it with my own, let me see what is going to return. If I greater than 15, print I. So what's going to return is it's going to return this guy 1, 2, 3, and 4. That kind of format. So let me see. So you can see that we have 4 values. This guy, this guy, this guy. No, this guy and this guy. So first of all, you go through the X's, then come to the Y. That's how it's going to look through. So it's going to look through the X first, then come to the Y and return the values that are greater than 15. But what I want is that, okay, return this guy if only this guy is greater than 15. Now, return this row only this guy is greater than 15. Return this guy if only this guy is greater than 15. But the entries in X that are greater than 15 are this, and this. So it means that I want it to return this guy, and this guy in a data frame format. So it is not going to return this guy and this guy because my X in that regard is not. So without wasting much about time, let me write it. So I'm going to say if For x in x, if uh, I want to use an AND operator here. I want to use AND operator. And sorry, before I do this, before I do this, I have to tell something. I should not go and pop up. Okay. No. Sorry. I don't know. Oh God. So don't mind. I'm trying to use the logical. You know what I want to do. Don't mind what I'm doing. I mean, this is not what I want. This one work. Okay. Uh for I in x bar. So I don't need to say for y in x bar. So I'll just say for I in, since I want it to return first, let me call my xy. Since I want it to return based on this guy. I won't say for based on the x column. So I won't say for I in x bar. So for I in in the column x, for I in the column x. So if I is greater than 15, print xy. No, no, no. There's a way I want to put in the AND operator here. This one is just going to check. It's going to check. So you can see that it returned 3 times. So let me explain what this guy actually did. Now, it checked this guy, it is true. So it returned everything, as you can see here. Now it checked this guy, it is true. It returned everything here. It returned the whole result again. It checked this guy, it is not true, it did not return anything. It checked this guy, it is true. It returned this third one. It checked this guy, it is not true. It did not return anything. So the ones that are true is 1, 3, and 4. 3 are true. So that's why it returned a result 3 times. But that's not what I want. I want it to return just these 3 rows. I don't want it to return everything. So that's what I want. So I'm trying to put a range there. But in Python, this guy is going to give me a kind of flexibility. So for I in this and J. So there's this kind of flexibility Python is going to give me over this. But I'm finding it difficult to fish it in here. If I is greater than this, means there's where I'm supposed to put this in. But this guy might not give me the flexibility. Sorry. I want to return this on columns. To return the jth row, I'm not having the flexibility to do this here. So it's not giving me the flexibility to do it here. The flexibility is there. So I didn't achieve what I want. I didn't achieve what I want. I didn't achieve what I want. So I think another way I can achieve this is this. So without wasting much of our time, let me call my XY again. So let me see. I want to use the which function. So I want to use the which function. Say x, y. I want to call it x, y. So the row is going to be which x. I want to use return everything. So for the particular row, I will explain this guy after I've done it. Don't mind me. Okay, I want the column x, which greater than 15, comma. I want everything, right? I want everything. Oh, which is not logical. Oh God. Okay. I'm supposed to be able to use this. I don't know why I'm not able to use this. So what I want to do is that I want to check, okay, for this particular column, check if it's greater than 15, then correspond it with. Oh, this is for row. Abi. So let me do this. It's not giving what I want. It's not giving what I want. But it's fine, sure. It's fine, sure. If I should see, I'm going to explain this guy later, maybe in the next class. I will explain what this guy does, maybe in the next class or before the end of the class. Let me just comment it out. How many of us has come across this which function in the maybe in the material or as we are revising? Yeah. Okay. So, all right. So in this, we have talked about the conditional statements and the for loop. So let's look at the while loop. Let's look at the while loop. The while loop. So we have treated the for loop like the basic. Now, what does this guy do? So let me just explain the basic thing of this guy. I can say so this guy, what this guy does is that, okay, while a particular condition is true, keep doing a particular process. So it can be something like, okay, let me use a basic example. Let's say as a student, I'm going admission to University of Lagos or Pascal University. So maybe after the end of the month, my dad sent me 20,000 at the end of the month. but the condition is based on while loop. And what is the condition? Okay, while I'm still in school, keep collecting 20,000 every month. So it means that the day I go to graduate from that school, I cannot collect 20,000 any longer. Do you understand? So it only keeps happening while that particular condition is still in place. So by that condition, another condition is elapsed, then that thing will stop operating. So I will keep collecting 20,000 at the end of the month as long as I'm still a student of University of Lagos. So that's just a typical example of how the while loop works. So let me see where I can demonstrate this guy in simple time. Let me see. There's a way I'm flexible with this in Python compared to in out here. So let's say let's see. uh, okay. First of all, I can put I should be able to put a word inside a for. Let me see. This now started again. For I in 1 to 10, for example, I can now say why I is, let me increase this to 20. I can now say why I is less or equals to 10. Okay, let me say print I. So let me try this. So what do you think it's doing? So this thing is not terminating. So you can see the thing is going, is doing the job, is doing the job, is doing the job. The thing is that I didn't put a condition for that guy to stop doing the job. I didn't put a condition why that guy should do the job. So it keeps doing it keeps printing it keeps printing no, let me stop this guy. Let me stop this guy. Sorry about that. So let me see. Uh, I want to see what I can do this. There's a way this thing is flexible when you okay. Okay, maybe I should put this one at the front of this guy. There's a way this guy is going to be flexible with. So what I want to do is that value minus one. Sorry. I want this guy to reduce. No. Okay. It's not. Oh. Okay, I think there's where I should tweak this now. This plane should come. Maybe this plane should come in between here. Then where we should go, the where should be here. Yeah. So I can't put this here. I'm finding it difficult to input. So what I want to do is that I want you to print just 1 to 10. As well, I can do this in Python, but in RE, it's not giving me that flexibility to do that. So this is part of what we are going to talk about next week. So that's because it's very important. It's very important. So not to waste much of our time. So let's go to the next agenda for today. Go back to why the next. So graphical analysis in R. I'll go to another. So I'll find a way to how do I want to put this? To write this guy, I'll compile everything, then send it as a script to our email. So you should receive that in the middle of the week sharp. So let me go to graphical analysis in R. So I'll put a comment in each of them so that you can understand what this step is doing. So graphical analysis in R. As when it comes to graphs, plots, and results, very edge when it comes to plotting graphs. So let me allow something. Let me allow someone to do. Dr. Magnus went off. So when it comes to plotting, you have a beautiful experience. You have beautiful experience when it comes to plotting. So it gives us a lot of. It has beautiful graphics. Don't just see it in that way. You have beautiful graphics in that. When it comes to that. So so we are going to see here.
Yes, sir. I was offline a while. I don't know what is wrong. So I just reconnected. Thank you. So did you terminate the loop, the while loop?
Yes. So I said we are going to.
Okay.
I'm going to send a summarized script about the loops, and so you can go about it. Yeah. I'm going to send the script to us via email. So I'm going to comment on each line of code.
Okay.
So what each line of code is doing as a script.
Okay.
So you are into graphical analysis with R now. So let's say a lot of this we can do this guy. Let's see. Yeah, there's this data I quoted. What's it again? I think my tab. Okay, yes, good. Let's say I want to create a plot. Now, if I do plot now, by default, let's say I want to plot the plot. Each image is so it said I should hit return to see the next plot. First of all, it gave me all this. Okay, it's now giving me something that is nice. So let me use the histogram. In that way. It's saying X month January report. I don't think that's that really matters. That really matters. What if I should do something like this? But I can't just cross Instagram with my tab because you have different columns there, which countries and that one. So is used to show the frequency of a particular the frequency distribution of a particular data. Let me see my tab again. Okay. So it's going to tell us. Okay,
Let's use X and Y now. Iman?
Yes, sir.
Let's use X and Y that has numbers. Wouldn't it be better?
Okay, X, Y.
For a history, for a histogram.
You see this now. If I should do this, this is this. Let us look at X, Y. This is X, Y. So first of all, you need to understand what we are even plotting in the first place. So if I'm saying X and Y, what can we talk about this particular histogram in the first place? So the histogram should be used to plot. We can there's a particular result there's a particular object here, table tab. Okay, table tab, yes. Table tab. This is what I want. There's a particular object that I saved as thing that has frequency. Let me see. As the table here. This is what it's particular object that I saved as data frame. Is it this guy? Yes, exactly. So let me use this to explore that. So, let me call it uh my data. So you can so yes. So let me call it my data. Okay, good. So I can come here now. This is how it's supposed to be. You cannot use histogram to plot numerical values per se. It won't really make sense. Now, what I'm saying is that let's use X and Y for example. This really makes sense because if I should talk about plotting this on histogram. So what's the X as what's the Y? Now, histogram is to show the count of the a particular element in a particular column. So let's say this apple now. How many times does it occur? This can be apple. The apple occurs 3 times, so it comes there. But if you are saying you are using numbers, doing an Instagram with numbers doesn't really make sense. Doesn't make sense. So you use Instagram for statistical variables. So let's see here. So I can come here for this guy now. I can say this. Okay, let's say our x is now our value can be it's going to be the first of all, let me call my data percent the first column there. Okay, I have this. So this can be my x, then my y can be my frequency. My data. Okay, so let me with this and remove this. Then Let's put this. So now this doesn't make sense. This thing doesn't make sense. But this is not what I want.
Why do you say it doesn't make sense?
Now the reason is that if I'm plotting this guy now, like this X and Y I'm plotting like this.
Mm.
If I'm plotting X and Y as an histogram, how do I want to relate this guy as an histogram? That's the first question. I cannot really communicate this data as an histogram. You can only
So
communicate
you can
yourself.
you can do either X or you do Y.
Now, if I should do if I should do this now, for example, X, Y for the first column, that's one. So I should hit return. Now this one is saying that 16.92 is around here. Let's say here it occurs once. 24.03 is around here. So there's a way it's around this side, it occurs one. Now 7.62 is around here, it occurs once. 15.49 is around this guy, while 16.92 is around here, it occurs twice. Why I'm saying it doesn't really mean that Instagram should give me the count. It should give me the count of
Exactly.
the
Give
particular
the numbers.
yes. So here what I want to achieve is
Yes.
that for this particular, let me use this example. Let me call it again. So for this particular column called fruits, okay, this part give me banana. Banana. How many times does it occur? Put the frequency here. For what do we call it? For maybe orange, how many times does it occur here? And like that. So that's what. Okay, let me just try to plot. Let's say my tab person. Let's say fruits. Let's see what we're going to have here. Need finance. Okay, let's see what is value limit because so unless I want to generate a frequency table for it. So let me see. I can let me see I can do that frequency of my tab. I want to see something. How does it work right? Okay. So I don't know, it's not giving me what I want in this format. So if I want to, the way to communicate this better is to maybe I want to do a kind of relationship between this guy and this guy. I can use a plot for this guy. So I will say my XY if you are percentage. I don't know if I can use a percentage because it's, it's a matrix kind of data. So let me just call O1 column 1 and comma XY column 2. So this is the relationship between these two columns. So X 16.92 is this guy that's around there. But the corresponding Y is X is 8 point this thing is around here. So this that gives me the first point here. And the second point, 24 points, which is this. The matrix is 12 point something, which is around here. Then the third point is 7 points, which is this guy. The matrix is 16 point something. Then this dot corresponds to the relationship between X and Y, which actually makes a lot of sense when you talk about numerical values. Now, I might want to see correlation between these two variables X and Y. But the plot actually plotting two variables, plotting two variables actually tells you about the correlation. Even seeing this plot tells you that there is no much correlation between the two. Let me edit this. Between the two column X and Y, because there's no relationship. Looking at this plot set. So if you want to even find the correlation, can use COR and put the two values you are looking for the relationship here. So this gives you minus 0.51. There's a negative kind of relationship. You can see if you want to even see it, you can just draw a line of base space like it goes down this manner, like it's going down. So that's why I have minus 0.5. So you can only draw the line. You can only draw the line downward like this. That it makes sense like this. Down going so it's going to give you a negative kind of correlation, but it's not strong. There's no kind of relationship. But let's look at another data. Say the iris data set now. Let's look at the chicken weight. Yeah, chicken weight. Now for the chicken weight, if you look at the weight and the time, look at the weight and the time, there's as the time increases, the weight kind of increase. So you can say that there's a relationship between with looking at the data, you might not really get the picture very well, but you want to get the picture, you can use the plot function. Plot the chicken weight and the chicken time. So if I hit return to see the plot now, look at this now. So you can see that increase in weight, increase in time is a kind of increase in weight. So it's a positive correlation. So if you want to check the correlation, you can just use the correlation function COR, then put the two pairs you want to compare inside the correlation function. This should give you a positive correlation. As you can see, you have 0.837 highly positively correlated. It's positively correlated. So even with the plot, you can see that there's a positive correlation that is very strong, a strong positive correlation. Now, you might want to see the correlation between each pairs in the data set. So let's say you want to see. So let me do the data chicken weight again, so that Where is this fluid again? I don't want all this other people to be there. So where is it? It's fine, sha. And I want to see the correlation, the relationship between all the columns. See wait time, wait check, wait time. I can just use the function called PS. Then specify checking with. This return to C plot. So there are so many of them. So this is for weight, this is for time, this is for check, this column is for diet, this is for cum sum weight for the cumulative sum, this is for the cum sum maximum, this is for the cum product weight. Now, this is saying that this is the graph for the weight and time. This graph for the weight and time as time for the x-axis and wait for the time for the y-axis and wait for the x-axis. This also a graph of weight and time as wait for the y and time for the x. So in this case, you can see. So this is weight and check. This is weight and diet. There's no real correlation with this. This one too, there's no. So all the ones that have this kind of correlation is this guy, this guy. So you can see it's going to pair them weight time, weight check, like a kind of form of two-dimensional plot between each of them. So this one is weight and weight itself. This time weight itself. So you can see the correlation between each pairs of variables in the data in terms of a plot. So that's what this does. Also, I want to see we are using some kind of data set. So let me log into my virtual lab environment so that I have access to those data sets. So I'm limited to some data. I'm not using the data in the R environment. So let me just log into my Blender so that I can use the data set they are using as an example in this session. I believe I should go to find it. The other one is how I'm doing it. Okay. Okay, so I'm using the lab. I'll open my R environment. Let me log in. If it's not if you can't see the screen very well, you can tell me to enlarge it. But let me do the console so I can see. I just use Control L to clear my console. How would I do it? If your console is still work, they want to clear all the things you have done. You can use Control L to clear the console. So I want to enlarge it a little bit. Okay. See me. way. What I'm typing is clearer to you. Is it clear this way? Can I see the screen very well? Or do I need to zoom in?
Okay.
Okay. So I'm using the constant. So first of all, I want to set my working directory to do home/do. Yeah. Okay. I want to import the data coordinate to read the it's in data set /daily .csv. It has an header, so I'll specify header first. That's why I'm specifying this. You can write it header equals to C or header equals to true. So let me see the head of daily spent. So this is the head of our data. So you have the person ID, person name, daily spend, daily earnings. And I want to see the length. So the length should give us the number of rows in the data set. And this is the number of columns. I want to see the number of rows. I can just do some kind of, don't mind this, just kind of manipulation. So you have 10 rows. So you have person name, daily need space, daily earnings. So this is the amount the person is spending. This is the amount the person is earning. So I'm earning 500 naira, but I'm spending. I earn 500 naira per day. I spend 100 naira per day. So it means that in a day I'll still have, like, after the end of the day I'll still have 400 naira in my pocket or something. So you can find profits. You can say profits is equals to daily spend per person, daily earnings, right? Minus daily spend per person, daily net spend. So amount to see profit. Okay, this is the profit of the day. So let's say I want to plot the person name with the profits. So the person name with the profits attached to each person. So this is for 400 naira. Average profit is this. Average profit is this in that regard. So I can do this plot person name. Persons. First of all,
we daily spend first.
Is that?
I thought it would be daily spend before the person's name. Is that not that's supposed to be? Okay.
So I can do this. Person. I want to plot a kind of histogram. So let me say daily spend. Daily spend, yes. Let's say a percent.
Exactly.
My profits. So I'm putting type is equal to H. So why am I putting this? I don't know whether you know.
A histogram?
Yes, exactly. It's a kind of histogram, but it's not the kind of histogram. It's not the kind of histogram. So what does this one says? We cannot see the remaining data. How many of them do you have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? But we are seeing just 1, 2, 3, 4, 5. We are seeing just 5. But the points you are seeing here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Reason being is that you cannot. This screen cannot contain this thing. What if it should be a larger version of it?
Why wouldn't it contain it? Why wouldn't it contain it? After all, the x-axis can be automatically calibrated to have the number between 0 and 300.
Something. I want to use this guy. I want to zoom. Let's see if you can zoom this. So I see now. It has brought out the whole point. So this for Barbara.
I was expecting bars instead of
this guy. Really.
I was expecting a bar.
Yeah. So he didn't give us a bar. Let me just let me we should be able to find something to do about that. So let's say plot, or let's type up plot, so we can see some properties of plot function. What type of plot should be drawn? Possible types are P for points, L for lines, so B is for boots, H for histogram like or highly density vertical lines, S for other types of steps, S for steps. So this is the type we have here. But let's see whether we can use this, whether this is going to make sense. This B. Let's change this B. Let's look at how this is going to be. Okay. So that's the way they can give us here. That's the way they can give us here. But let's check for it. So okay, I want to do something. So let me bring uh this guy. This guy we're trying to plot that time, my tab, which is this guy. So I want to generate these results using histogram. I want to generate this result using histogram. So let me go and call the this is the line of code you go to generate the data frame. So I go to my virtual lab environment and achieve the same result. So let's see my tab here. Okay, now I want to do a plot for this guy. First of all, I will say frequency, but let me first say table of my tab. I want to do a tree. Now, if I want to do, I will do row. Sorry, I don't want it this way. F tab. I want F tab. Okay, I just want for foot. I just want for foot and countries. So table my tab, ampersand. put my tab as an control. Yeah. So I will do a row sum for fruits. So I'll say my fruit is equals to row sums. Yes. Row sums. Let me call you something. So let me call something. So my tab. So my fruit. So what I will now do is that okay. So let me guess. My fruit. I want to use the idea of this guy. So my x in this case will now be the values I have here. It's going to be my x. No, my x will be types of foods we have. So I will have x label. X label to be the types of foods we have. Then frequency. What the frequency we can have? Let's see. I want to add this. Moving on. I will explore this data and we can tweak it. So let's see another thing we have here. We just did a plot for this guy. Now, which is this? So let's say we want to let's call our data our head of daily spend again. Okay, let's call our daily spend here. So let's say we want to see the relationship between daily spend and daily earnings. We just use the normal plot function. That's daily spend, daily, daily spend by daily earnings. Then this one is going to give me like this. So if I want to inform, it looks like a scatter plot, but this one is not. The data is not much. Let's start a data that is much, and let's see the way it's going to be.
It will still be the same thing.
Yes, but you're going
It
to
will
see,
still be the same thing.
but it's going to be much more. But let's use this like point.
I think the difference is that just like in Excel where you select the type of a chart, it's like we've not been able to select the bar chart.
Yes.
That will give us what we have been trying to get.
Let's see how this guy plots the data. There's a function called points. Let's compare how it's going to plot this guy. It's still the same thing. I want to change the color. Okay, I don't want the color to, by default the color is black. Let's say I want to change the color to red. So you have a red color. So let's say I want to put a kind of line of a line to show the trend of the graph. So I can use this function. Then specify that this guy, instead of putting this guy, I can write, okay, this is I'm modeling this guy with this. I think I don't need to specify color or something. It's not giving me the form of the line. Giving me the form of the line. Maybe because the data is not much. So let's use another kind of data. Okay, let me call this void data. To illustrate what I'm talking about. P.csv. Sorry. And put this particular data set. From data set, we have a data called scatter CSV. That's the header. Because let's see the head of the data. Okay. So let's see. Let's kind of plot it. For data ampersand AA, comma, for data ampersand DB. If we can see how this one is more compressed.
And this is also a scatter diagram.
Yes. So let's see. Let me copy this and put here. Let me put something like this and just put outline here. And let's see how to model this in the form of this. I still don't have nothing. Oh. I guess. So since I'm just doing a normal plot, if I want to get the trend, is like I'm doing a kind of linear model. So that's if I want to do this. That's why I'm going to have this kind of line that will occur here. So it's showing the line of best of fits. If I should plot this guy as a model, that is my y-axis, my y dependent variable. So I'm modeling this, taking this as my dependent variable, and this as my independent variable. So this guy is line of best fits you can find. But so that's when this is going to come in. So if I'm actually using this, I can even use plots. Plots should actually give me the same results if I'm talking about this. So let's see. So if I'm doing a linear model of it, a plot, I don't think I necessarily need to put this there. So it's still the same thing. So it must give us that line. It's that line of best between the two variables. You can tweak color, the dimension. Let's see. Let's see. You can pick this guy. Maybe you don't want this kind of point. Maybe you want a dash. Maybe you want anything. You can pick it. Let me see. The table for that. Maybe you don't like the look of the graph. Sorry. I'm going to save us the stress. I can actually come here. Okay. So let's use the help function again. For plot. What's with? I'm not telling it to plot now. Okay. First of all, I have to eat it down. These are the kind of plots we have for it. So that's why it is a this. So let me see the plot function. So yeah. So as you can see here, we already. So you can see if it is line, the kind of line you want. If it is point you want, you have it here. So if I want it to be lines and not straight, then I can come here, for example, this guy, and put L here to have this kind of plot.
Why is the line not continuous?
No, it can't be continuous. It's a point. It's a point. So instead of having it as like a circle, it's doing a straight line to demonstrate the point. So instead of having a circle, that's just the difference. So you can put X label, you can put Y label. So if I want to add to this guy, I can say X label is names, I want to call it names. Then I can put Y label, say Y lab is equals to what's the Y label? Okay, profits. I can call it profits. So this will be included in this. So I can see that okay, anybody that sees the plot that okay, this is the names. You can put names of employee, any which way, and this is profit. And you want to give the histogram a name. So you put a parameter called name. See, I can say, what should I even put? Spending pattern or spending weeks by persons. So this is going to be like the name of the plot, as you can see here. So you can also do that. Now you can do something like this too. Let me first see this guy. Let me move this L. Let me move this L and put maybe what do we put? B. Okay, sorry. Let me put H. I'm not seeing the result. It's not going to be the result.
You're putting B now.
I put H. Okay, let me use this. Let me use this for example. No. Sorry. So let me say I want to plot this guy. I want to plot this guy. So, as you can see here, you can see the dot is kind of big. I don't know. Maybe I might want to reduce the size of the dot, the particular size. Use this PCH. It's like the pixel. It's like the pixel of the dot. So let me say I want to use 10. Let's see what we are going to have in this regard. You can see what you have here. let's say I want to put 5. Okay, it's the kind of the shape of kind of maybe it's diamond, maybe it depends. It depends. So if I put 16, you have this kind of thing as the points. So each of them, they have their own functionality. So anyone that suits you, that you think that is fine to put, you can explore that also. Okay, then there is what we call box plot. A box plot is actually used for categorical variable. So let's see an example of the data we can use for this case. So let me import the data set so you can see how a box plot works. So there's this data set they use there. So let me just call it explain data. Then read dot table data set. Com explain.txt. So they use the table because it's the txt file. So a read.table file, read.table function used to import a kind of data that is not mostly CSV. If it's not a CSV file, you can use for CSV format and put a separator value there. Separator parameter. So let's see the end of this data and see what we have. So we have this guy. The exp column is a categorical variable. Let me see the detail. Okay, we have this. So calculate that and variable. So let's see. I want to plot. Now I want to plot this guy. With the exp against the output. Now this is my x, which is like the categorical, and this is the numerical value. I want to give it a label. So x label is equals to exp, and this kind of the expenditure or something. I don't know what is it. So y label is equals to this output. So you have a box plot. So a box plot gives you a 5-number sum. So this is for control. So this is like a plot for control the it plots each categorical variable corresponding to the output value. So for R10, this is the plot for R10. For R5, we have this. For N50, for N25, and the like. Now, this plot is going to take into consideration some things. So, for example, I want to say, let's see the summary of expenditure data. So for the summary of the table, we have minimum to be this, for output, maximum. This is So I said maximum. This is the first quarter. This is the median. This is the median. This is the third quarter. This is the maximum. So maximum is 731. Now that corresponds. You can see that actually corresponds to N25. 731 is around this guy. Are you now the minimum is 415, and that corresponds to control here. Now let me explain. For control, this is the maximum value for control. This is the minimum value for control. For N25, this is the maximum. This is the minimum. For N50, maximum, minimum. For R15, maximum, minimum. For R5, maximum, minimum. Now I want to do something now. Can I query this table, this EXP data table, to give me the results for control? Yes. So I can do EXP data as no, sorry. Okay. So let me just do this. Comma EXP no. So I want to do for which so let me just do which into EXP. I think I have to use this which. I think I have to use this which again. Which EXP. Sorry, I have to come and put EXP. So I can use the is equals to, let's say, control. Let me see what I'm going to have. Let me use double equality since I'm doing a comparison. Okay. So for control, these are the values we have. 19, 20, 21. I don't kind of trust. I don't kind of trust that I have here. I have trust issues. So let me do for R10 instead of control. Since I know I can see R10 here from the edge or from the tail of the data. Let me do R10. I just want to verify whether I'm not doing the wrong thing. Yeah. Okay. Do you know what actually happens? Hello. So what actually happened is that it gave me the index, the position of the data whereby we have this R10. So I think I understand how this works now. So I can actually call it. Yeah. So I can actually call it based on the index.
In the next 20 minutes. How far? What is it? Okay.
So let me just Hello. So does this make sense to us? So for R10, this is the this was what I was trying to do when I was using the which function before. So which this equals to R10. This one is going to fetch me the index for which I have R10 as the value in this data. So it's going to give me the index. As you can see in this result, it gave me 25, 26. So this 25, 26, 27 to 30 is passed in as a vector in my row, But I want it to return all the column. That's why nothing is here. So this guy is passed on as a vector as the row. So it fetches the position of the data that has R10 in the exp column and passes as a vector here. Then it's going to return everything in R10, as you can see here, that it is everything in R10 here. So for comparing with this, what's the maximum value here? 679. So this corresponds to the maximum value you have here, as you can see here. This corresponds to the. I want to sort this result. So let me use the sort function. I think the sort function. Sorry. On the 5 columns. Okay. I have to specify a column. So it doesn't matter. So this is the highest value 679, which matches with the maximum value here. So what the box plot gives you is minimum, maximum. It gives you the first quarter, the second quarter, which is the median, and the third quarter. So this also should give you the median. The median here is going to be, first of all, arranging this data in ascending order. Since I have 6 values here, so the median is going to be the 2 middle values. So it's going to be two values in the middle that's going to fall in the middle. So how is this going to calculate the median? So add the 2 values and divide by 2. So the median is going to correspond here. So where is the position of the median? Is this guy. While the first quarter also falls in here. So that's box plot for you. Hello. I don't think I'm the only one here.
No, I'm listening. I'm listening to you.
Okay.
Yeah.
Let's just keep looking at
You're gonna send the script of this one as well, right?
yes, I would.
Okay.
But this one I'm writing here is in the VMware. So I'm going to do a description. So I have to copy this. Maybe I can copy this thing into my local house studio. If I can copy it, then I will write a note before. I'll say this script should be run in the VMware so that the data I'm extracting here is from the VMware, and I will specify the instruction there.
Okay.
Yeah.
Thank you.
So let's also see another kind of plot, a time series graph. A time series graph. So there's a particular data in R Studio that is a time series, that's in time series format. So the time series class is called TS. So first of all, let me call that data air passenger. This air passenger is a time series kind of data. Now, if I want to check the class, I can say class air passenger. So if I should run this, you can see that it gives me TS, which means time series. It is time series kind of data. So if I should plot this, just look at how the time series data looks like. I believe you know what a time series is. But if I say time series data, we know what it means. So this is the kind of plot you have.
Okay.
So you can also use what we call let me call the particular data. Sorry, I'm not typing in here. We call the UK. I can't find this. I can't find what they list here. This is what I can find.
Iman?
Yes, sir.
Iman, sorry, I was distracted for a minute. We were thinking about time series and you put, say, TS. I didn't see TS in the passenger.
You can see where my mouse is pointing out.
Okay.
So I checked the class. So the air passenger data is a TS is a time series data. So if the class is yeah.
I've seen it. Okay.
So I guess we all understand what the time series data is. I've forgotten that I'm talking to an economist.
I was just listening to you.
So data, I'll check the end of this data, UK debts, blah blah, UK debts. Is a time series. Let me check for 20 entries or 24 entries. Let me even look at the data itself. UK driver. So this is what we have. This is how a time series data looks like. So for this particular year, you have this month. So these are the data we have for each month in this year. For January 1969, this guy and all that. So if you plot this guy, if I should plot this guy, let's say TS. So what am I saying? UK yes. Yes. You have this kind of. Now let me take us back to my local output. I want to show us something. Now you might not have your data in this kind of format. There's a way you convert your data to this kind of format. So I'll teach us how you can do that now. Before we now go to Python, I believe we have more time to do that. So let me take us back to our R studio. There's a data set I have in my local here. It's a Bitcoin data. So it's a time series kind of data. Now, I don't know whether I should use that. Okay. So it's I think I should have it stored here. So I should have it here. So this is the data. This one is already in. I've converted it to time series format. I don't want this. So this is what I want, yes. Or I don't want this again. I don't want this again. I want there's one that is okay. Let me check my downloads. Okay. It is my here. This is the up. So let me check. I don't want this format. So I'll just use this scan or read underscores read.csv. Y is equals to file.choose. So I want to choose the data. It has already prompted me to choose select my data, but I cannot see it in this screen. So let me just, yes, I can see it now. My data is under downloads. Under downloads, I go to downloads here. Where is my downloads? Okay, downloads. Let me check this guy. Maybe I have it. No. Let me check this guy. Or let me just include the raw data itself. Where is this? There's this. Yes, exactly. So I have the data. So BTC, I'll show you something. Add BTC. So this is what you have. So you have currency, you have date, you have closing price, you have this, you have that. Now, let's say these are time series data. This one is entering a daily basis. The format I've already compressed it in monthly basis, but this one is entering daily basis, as you can see here. Let's say I want to do a time series plus for this column, for closing price for this guy. First of all, I want to rename the column. I don't like the way the column is. So names. Sorry. So names. The name is too long, so I want to give it a nice name. BTC is equals to. So let me call it currency. The name is still ambiguous. So I want to call it, give it another name. So date. Say closing price. Say opening price. Say high price. Say low price. Okay, so let me call the head again. So I've been named the column this way. Now, let's say I want to plot a time series plot for each column for the closing price, opening price, high price, and low price. I should be able to do this using the ts.plot. So ts.plot. First of all, let me detach. Let me attach. It's not necessary. I can just say, okay. For me, let me attach it. Attach PTC. So I'll say ts.plot. Then I'll specify closing price. I want to do closing price. Closing price. Opening price. High price. I want to do low price. Then let's see X label equals to year. I don't necessarily to put this. So let's see. So the command. Before I want to is not giving me what I want. Oh. Maybe because the data is not in time series format, that's not giving me this. But this is already in time series format. Okay, no problem, Sha. No problem. So let me call another data. So I want to explain how you can convert your data to a time series format like this. So let me use another data. Let me call this BCC world. I think there's a kind of data I used in that regard. So let me use this. So let me call PTC all. This is not what I want. Let me see this one. No. No. Let me check the last one. Okay, this is exactly what I want. So as you can see here, you have 2013. On 2013 October, you have this. 2013 November, you have this. Now, I want to convert this data to be in this format.
Okay.
How do I do that? I'm going to use, so it means I want to go to time series format. So I use TS into bracket, then, okay. Now, what I'm going to consider is this guy. This column that we call ABG underscore close, blah, blah, blah. That's the third column exactly. So what's the name of the data set in the first place? BTC underscore all. Then I'm picking the third column. So I'll specify this. Now, where is this starting from? I'll specify the starting point. So how do I specify? I started from 2013. But from which month? From month October, which is like the 9th month, 10th month rather.
Yes.
Okay. Now, I don't need to specify the ending, it doesn't matter. So what's going to be the frequency? The frequency is 12 because there is 12 months in a year. So if I should run this, you can see what I have. 2013 October, 2013 November, then it goes to 2014. Then it stops at 2019 December. In this regard. So do you understand that?
We have to understand them.
Susan, please, do you understand?
Which of the dates conversion you did now?
What did you say?
I think yes, are you talking about the date conversion you did now?
Conversion. First of all, this is the data I'm using, BTC underscore all. So these are the data.
Yeah, I can.
So in this data, we have year, we have month name. I've already done this conversion like the way it is like this. This is not the way the data is. So the way I did this, I already did this in SQL to get, okay, for each month in a particular year, what's the average closing price? I got this. But now, how can I now convert it into a time series data in R? Now, so I'll use the TS function to do that. What we are doing in this case, the time series data itself, which is the price. Are you with me? And the price will be in column 3. That's why you have comma 3 here. Now,
Okay.
where is this starting from? Start is equals to, you put it in a kind of column vector, in a vector. It started from 2013, quite all right. But it started from the 10th month, which is October. Are you with me?
Yeah.
So what is the frequency it should pick? So it's going to do it in months. So frequency is 12. So okay, from October, yeah, start picking October, December. So what it does is that, okay, this data 2013 for January, nothing is available because I'm starting from nothing is available for January to like September. But October, which is the place I'm starting from, it picks the first entry. Yeah. Second entry, then to December. Then since 2013 is exhausted, it goes to 2014. So January it picks this. Then in that format in 12 months. So it will do it till the end, when it will stop. So don't specify stopping where you're going to stop. But if you want it to end in a particular place, you can say end. You can put this particular parameter end. Maybe you want it to end at 2019 at the 12th month. then you specify this. But since you just want to do it for everything, you don't specify ending. The function is going to know where to end. So you just pick it to the end.
Okay.
So this
Okay.
is
Okay, Iman.
sir.
In the model, instead of using 3, can we write the variable name like AVJ underscore closing price?
Yes, you can do that.
Okay. Then if we want quarterly entries every 3 months, which means in the year we are going to have 4 entries.
Yes.
So what do we use for the frequency? 4?
Yes, I want to use since it's quarterly. It's quarterly. It's 3 now.
Sorry, yes, 3. Sorry, it's quarterly, so it's 3. So have 4 quarters in a year.
Yes.
So we'll pick it will pick March, June, September, December.
Yes. Let's see. Let's see.
Okay, let's see if how it goes.
This is what we have. So let's see how that goes. We pick 149. So what's something? Let me see this result first.
But it didn't pick the months. I was expecting the months to.
It's not even picking the way it's supposed to pick. It didn't pick the way it's supposed to pick. So first of all, let me specify this to be if you are doing it quarterly, I think you should be able to let me say one here. Let me see this. It's 28 and 82. Let me see this guy. So it's doing something at the background, but I'm still not getting what it's doing. But I'm not sure quarterly. But if I actually want to do quarterly, I would have done a tweak before coming to the hour.
Okay.
Let's see. You can use the help function to see how that's actually. So let's see the parameter. So the time of the first organizer is number frequency. Understand the frequency. So let's see.
Diminishing return asset,
Diminishing return asset.
Seriously.
We are going to finish the class now.
I'm going to do what?
We are ending the class now. So
okay.
So I will find this script and send to us. I will find this script and send to us when the result comes out. Then discuss some things probably we're not able to touch. Earlier next class, I will know.
Okay.
All right, no problem. Thanks for your time today.
Okay, thank you.
Thank you so much.
Thank you.
Susan, remember your promise.
Till then,
okay.
Doctor.
Blessed day.
Bye.
Okay, bye.
All right. Bye, sir.
Okay, Iman?
Yes, sir.
I will call you. Which day will be convenient for you?
I said Monday now. I said Monday. We'll talk.
Okay, I'll call you on Monday.
All right, sir.
Okay, take care.
Okay.
Okay, bye.